Tuibariki Tanzania, dumisha uhuru na umoja, wake kwa waume na watoto. Mungu ibariki Tanzania na watu wake. Ibariki Tanzania, ibariki Tanzania, tubariki watoto wa Tanzania.
Are you a pre-form series student who has been looking at an online secondary school that can teach you the beauty of basic mathematics? Or are you a Form 3 student who has been struggling on how you master basic mathematics for the rest of your life? Or are you a parent or a guardian or an uncle or a brother or a sister or a mother or a father of a son or a daughter who is pursuing ordinary secondary education, and actually you've realized that your son or your daughter is experiencing so many difficulties in comprehending basic mathematics? So the answer of all those questions will be given in this session, and I would like to ask you to stay connected and stay tuned into this fantastic moment. How are you, everybody who is watching this video? I'm very happy to have you today, and I would like to take this opportunity to welcome all our online family, or our national online family and international online family of students. My name is Olenjolai Moko Tayai Losingo. Simply you can call me Olenjolai. I thank God by His own grace who has given me a gift of teaching. I am teaching and teaching is me. And also, in addition to that, God also has given me an opportunity to be a national teacher of basic mathematics, a national teacher of physics, a national teacher of chemistry. I am a citizen of a kingdom of heaven, and also I'm a citizen of Tanzania, and this is our national flag. And I want to tell you that in advance I'll be using the syllabus of United Republic of Tanzania when I'll be teaching you about the beauty of basic mathematics in this session. However, the basic mathematics we're going to learn is international, so it means that it's universal. So even if international students, you have to stay connected. I thank God who have made me to be an international student, because I know this program will also have students from different countries and different continents. So my dear student, I would like to ask you that to be a serious, active online student who would like to see the change, the transformation from failure stage to the advancement stage. So I thank you for, again, thank you very much for singing our national anthem. Mungu ibariki Tanzania, Mungu ibariki Tanzania. It's a chorus of our national anthem in Tanzania. And actually, that those are the words of blessing. You've been blessing our country. And ourselves as Tanzania, would like to bless also your country. So I would like to welcome, and I'm very happy to have you, whether that you are a slow learner in basic mathematics, or you are an intermediate learner in basic mathematics, or you are an advanced learner, or you are a faster learner in basic mathematics. I would like to ask you that to stay connected and then experience something new in your life. So keep enjoying. So whether you are a national or international student, I would like to take this opportunity to welcome you into this fantastic moment where we are going to break down the challenging concepts about basic mathematics. So whether it's your first time or second time or third time or fourth time, you're only welcome. So before even we start, we keep on with sessions 8 of solving questions of domain and range of relation. Let us surrender our life to God and invite God firstly, because God is our first priority, and God is the founder and sponsor of Tanzania Online Ordinary Secondary School, in square bracket Olenjolai. So let me and all my online students, national and international, join together to have an alpha prayer or alpha opening prayer. So let us pray. Our Father who is in heaven, we come before your presence as your children. We repent firstly for all our sins, for all our transgressions that we have committed before your present Father, and also before your throne of grace. There is the judgment, or there's a case which has been brought against us, that we have committed sin, transgression, iniquities, rebellions, and wickedness before your present Father. Father, we confess and forgive us and wash us by your precious blood, so that you may enter into the kingdom of heaven and enjoy the beautiful of the kingdoms of heavens in solving real life problems. So Father, we come before your presence. We say thank you for forgiving us. Welcome right now to be a great teacher of session 8 of the topic of relations for basic mathematics form 3. Open the mind of all the form 3 and pre-form 3 students, private candidate students, students who have given up. Father, open their mind to understand every concept that I'm going to teach them, and let them apply to solve small-scale real-life problems. My Father who is in heaven, I thank you because you heard me, and I give you all the glory, and also I and all my students will give you all the glory and praise. Amen. Thank you very much for joining me. Okay, secondly, I would like to take this opportunity to welcome all our national and international students into our Tanzania online secondary school that's called the Olenjolai, square bracket Olenjolai. Simultaneously, welcome into our official YouTube channel that's called Tanzania Online O-Level Secondary School in square bracket Olenjolai. We have more than 3 departments. One department is basic mathematics. Welcome departments of basic mathematics, where we are teaching you 4 subjects: basic mathematics form 1, basic mathematics form 2, basic mathematics form 3, basic mathematics form 4. And then the subject of the day is called basic mathematics. So today we are teaching the students from these classes. So we are teaching from 3 students, means the students who are getting prepared to join Form 3, Form 3 students, QT students, reciters, grade 10 students, or Form 4 and Form 40 and Form 4 students. But we are also teaching teachers who are teaching basic mathematics. We are preparing teachers because we know that we cannot do this work ourselves. So through our learning, teachers also can go through and can learn from us, as the way that I used to learn from other teachers. Okay, so the topic of the day is called relation, and this is session 8, solving questions of what of domain and range of what of relations. That's what we are going to teach you. And the other piece of information, these are not related with today's session. This is all related with programming. So I have to teach you about solving questions of domain and range of relation. So before we dive into our today's session, I still have few informations for you that can help you. The first question that's going on in your mind, if it's your first time or second time or third time, so maybe you didn't meet with an active and systematic online training education center, online training education center, by using the videos. So then the question going in your mind, how can you interact with me? How can you ask me a question? How can you give me a feedback when I ask the questions in the class? Why Olenjolai and all his students are not physically connected. So we are wirelessly connected. That's a very good question. So at the moment, you may use the comment section below in these sections of the video you're watching right now to ask your questions, to give us feedback about your understanding, to give us your testimony, to tell us anything else that you find, just to tell us the advantages of this program. And then use the comment section to submit the homework, to ask the questions to other online students. So comment sections, actually, it's a public section. So it's a public section. So use it effectively, and any comments you write, I will read it, and I will try my level best to answer your comment as well as I can. So use this comment section to interact with me. I like questions so much. Again, another piece of information that maybe it's your first time. How can you register yourself? Is this an ongoing project or just for session 8? My dear student, this is an ongoing project, and this multinational project and the generational project. So for you to be an active student in our official YouTube channel, please look the buttons where written subscribe, click it, and once you have clicked it, and then the icon of the bell will appear on the right hand side. Click that icon of the bell, then you have to choose option of all. So from there, you've registered yourself free of charge. The only requirement for you to register the YouTube application, and also you must have an email, and remember your password and OT and username. So from there you've registered, and you receive notification whenever you are online about a new session of relations or from theory, maybe of basic mathematics from theory or physics or chemistry. So that's very important information. But sometimes you can have a doubt, you don't trust it. You can spend sometimes, you can go through this session for an hour, and then from there you make a permanent decision. But one thing which you want to tell you, this is an online school, so you should be an active online student, and you have to make sure that you get connected into our online school every day. Every day. If you are studying a day school, this is comfortable, and just it's an excellent online schools, because actually that once you are done with your school learning sessions during 3 p.m., then from there you can take advantage of the also. So let us go into today's session. So are you ready for today's session? Are you ready? I'll be using the syllabus of Tanzania, but the best mathematics that I'm going to teach you is universal. Okay, so the concept that we are dealing with is domain and range. So we want to solve the problems about domain and range. So let us do quick review. Quick review of previous session. The previous session is session what? That is session 8. So the previous session was session 9. It has been titled Domain and Range of 40 of Relation. Firstly, this session is titled, or we call it Domain, so you can access in our official YouTube channel, Domain and Range of 40 of Relation. That was session 7, not 9, excuse me. Domain and Range of 40 of Relation. So we taught you, first of all, what the meaning of 40 of domain of relation. Because in basic mathematics, we have domain of relation and also have domain of 40 of a function. So what the meaning of domain of relation? So simply it means that we answer the questions, what is domain? Domain of what? Domain of relation. So we define it, we gave you a definition. Domain of a relation is a complete set of the possible values of the independent variables of a relation, or is a complete set of possible values of what? Of x. So simply say that the domain of what? Of a relation is a complete. So it's a complete what? It's a complete set. So it's a complete set of 40, set of possible values, complete set of possible values of 40 of x. Then we taught you what the meaning of 40, or how do we write domain? Okay. So in mathematics, domain of relation, you can write it such that this way. Then we say that maybe x is an element of all real numbers. So we have different styles of writing, but we use the curly bracket whenever we want to describe what domain. But another key point before we taught you about range, then we taught you that domain, say that is the value of what? So it's a set of value. So it's a set of 40 of values of x, but we make what? But we make y the subject. Make y what? The subject. Okay, so then we taught you again about the meaning of 40 of range. What is range? What is range of 40 of relation? So the range of relations, we define it as what? The range of relation is a complete set of possible values of dependent variable. So simply this is a complete set. Let me just remind you, because we are going to deal with them. Complete set of what? Set of values So complete set of values, of possible values, complete set of possible values of the dependent variable of what? Of relation. While domain is a complete set of possible values of x. Okay, no, it's a complete set of possible values of independent variables. So instead of x, we can say that independent, however, that the independent variable in relation independent variable. In most cases is what? Is x. Y dependent variable in most cases is what? Is y. So the way also we write that range, we used to write range by using the curly bracket. That's the mathematical notation that we have to use. Then we did some examples with you, and we left the homework to you, which was example 24. And now we'd like to do correction of example 24, then we have to continue. Okay, so if you have missed this session 7, you can access in the playlist called Relation in our official YouTube channel called Tanzania Online O-Level Second School in square bracket Olenjolai. Okay, did you understand our quick review? Okay, keep enjoying the beauty of this mathematics. So today's session, let us start with what correction. Let's do correction. Correction of what? Of homework 7, which was actual example 24. So I won't rewrite the question because you have it. Let me read it and then we are going to solve it. If R is a relation of two sets x, y, or x, y, such that x are real numbers and y is equal to 3x squared. Find all ordered pairs which belong to the relation when the domain is 0, 1, negative 2, 2, 2 over 3, square root of 3. But let me just take an advantage of it. Let me write the question in order to help maybe the new students who didn't go through the previous session. However, I advise you to go to the previous session before session 8. So if relation, where we have x, y, such that x is the element, or x are real numbers. Are real numbers, and y is equal to 3x squared. Find all ordered pairs. Find all ordered pairs. Find all ordered pairs which belong to relation R when the domain is 0, 1, negative 2, 2, 2 over 3, square root of 3. Okay, so that the question we have to state the set of ordered pairs. So you say that if a relation R is that one's whereby the values of x are real numbers, all values of x are real numbers, and y is equal to 3x squared. Find all the ordered pairs which belongs to the relation when the domain is that. So solution. So what the means of ordered pair? Solution. So remember that the first thing first step, matter given. So first of all, the question starts with what? So we'll be given a relation where we have x, comma y, which is ordered pair, such that x is an element of 40 of all real numbers, or real numbers, and what? Y is equal to 3x squared. So we have a responsibility of finding what? All ordered pairs. So all ordered pairs of relation. This is what required. So we say ordered pair will mean x coordinate and the y coordinate for each. But we'll be given what? Domain. So what the domain will be given? It is 0, 1, negative 2, 2, 2 over 3, square root of 3. So that's the domain. So simply to find, in order to get the all ordered pairs, we have a domain. So an ordered pair actually contains x and y coordinate. So remember that something called ordered pair. This consists of x, y. So it means that simply you have to find what range. So the second step. So let us use question y is equal to 3x squared to find what? Find range of relation. So you may either use a table or you may use what? You may use a normal method. So what do you prefer? Okay, so I think that let us use the table. So here we have the table. In this table we know the x coordinates, but we don't know the y coordinates. So x coordinate, y coordinate, which is equal to 3x squared. So 3x what? 3x squared. So we have different values of 40x. The first one is 0, 1, have also negative 2. This is not a table of values, because a table of values, okay, you can call it a table of values where the domain is restricted. So here we have 2 over 3, and here we have 140. So because we don't need this space, we need this space and further, and this is our table. Good, so we label it table 8.1. Say that table of ordered pair. Ordered pair. So we begin y is equal to 3x squared. So let's say this is y1. So when x is equal to 0, y substitute x is equal to 0 in the equation y is equal to 3x. So this will make 3 times what? 0 squared. So the response is what? Is 0. Then let us find out y2. So y2 is we have to find a y coordinate corresponding to x coordinate equal to 1. So substitute 1 in x squared. So we have 1 of the square. So 3 times, or 1 times 1 times 3 is equal to 3. Then here it is y3. I have y3, what do we have? So y3, we have 3. Next x coordinate is negative 2. So square. This will make out 3 negative 2 square. This is equal to negative 2 times negative 3 is equal to positive 4 times 3 is equal to 12. So then let us keep finding the other values of y. So let's call this is y4. Okay, y4. So y4 is when x is equal to positive 2. So substitute x by 2 square. So the response is what? Is 12. Then here we have y5. y5, 3. Then you have what? 2 over 3 square. This is equal to, so this is equal to 12 over 9. 12 over 9. Why? Because this will be 4 over 9 times 3 is 12 over 9. You can simplify it, or you can leave the, okay, yes, you can simplify it. So y5, you simplify by 3 is equal to 4 over 3. Then we have y6. y6, you have to find the value of y corresponding to square root of 40, square root of 3, then you have to square. This will make 9. So now you can fill the corresponding values of 40 of y. y1, when x is equal to 0, y is equal to 0. When x is equal to 1, y is equal to 3. When x is equal to negative 2, y is equal to 12. When x is equal to 2, y is equal to 12. When x is equal to 2 over 3, y is equal to 4 over 3. Then when x is equal to square root of 3, y is equal to 9. So from there now, we can conclude our response. So the third step said that use table 8.1 to write the set of ordered pair. So we say therefore the ordered pair of relation that we've asked you to find is equal to it. So you start with curly bracket. So the first t, the x coordinate is 0, y coordinate is 0. Then here it is. This is 1, this is 3. Then there it is what? Negative 2, comma 12. Then you have what? 2, comma 12. Then you have what? 2 over 3, comma 4 over 3. Comma what? Square root of 3, comma 9. That's the final response for that question. So now, if you understood the corrections of the homework, please let me know in the comment section below. So if that's the case, now let me teach you how you can solve different questions for finding domain and range of relation. I know many students, they used to struggle on comprehending the steps of finding domain and range of the function rather than range. So sometimes some of the questions are very tricky. Okay, so my dear students, now it's a time for solving more questions, and that's the title of this session. And this is the reference book I recommend to every student. It's called Secondary Basic Mathematics Book 3 by Tanzania Institute of Education. And this is a recommended book which has been written according to the syllabus of the United Republic of Tanzania. So every Form 3 Tanzanian students, you may order this book. You may find it in your local market or in your local shop, but you may order this book online from our Tanzania online ordinary book store. And it's a very cheap price, so we can order it at a very affordable price, and we can send it to you at any time and anywhere in Tanzania, including Unguja and Pemba. So how? Please send a message to me through that telephone number. So in this book, if you open, the first topic is relation, and then let us go into the exercise 1.3. That's what we are going to solve. Our problem solving today will be focused on exercise what? So for international students, you may ignore the name of the book. You can just focus on the question and concept that we'll be teaching you. Refer secondary basic mathematics book, students book, by Tanzania Institute of Education, and specifically for this case, let us focus on exercise what? 1.3, and it is in which page of the book? On page 23. So we'll be solving questions from this exercise. So simply, ladies and gentlemen, this is the example 25. As we say that to refer means that refer exercise 1.3 question. So let us start with question 2. Question 2. And here it is. This is the statement of the question. If a relation R, which is equal to 3, 4, then 3, 6, 4, 5, 2, 4. So if the relation is a set of ordered pair 3, 4, 3, 6, 4, 5, 2, 4, so if that relation is given, then write down its domain and range. Write down its domain and range. So you can pause the video and try to solve this question. It's not difficult, you have just to follow the steps. And here is the solution. So the first step, we say that domain is a complete set of what? So say that is a set of possible values of 14 of x. So domain is a set of possible values of 14 of x, while range is a set of 40 of possible values of 1. So simply you say that domain for the given problem, so domain of a given range, straightforward, these are it's a value of x coordinates. So it is 3, 3, comma 4, comma 2. That's the domain of what? Of the range. A domain of what? Domain of the relation. We have range of what? Of the relation. So the range of relations, these are y coordinates. So what are the y coordinates in the given range? 4 as a y coordinate is 6, as a y coordinate is 5, as a y coordinate is 4. But the response. Okay, did you understand how we solve together example 25? Please let me know your feedback about operation of example 25 in the comment section below. So now we are still solving question. We want to encourage you to solve exercise 1.3. So here, this is example 26. And you have to refer the same book and the same exercise. Exercise 1.3. Now, I would like to solve Let's solve question 1. Let's solve question 1. So, how does question 1 state? So the question states that if a relation R where x comma y such that x and y are real numbers, y is equal to x cubed. Find a set of ordered pairs belonging to R or belonging to relation R whose domain is, then with the curly bracket, 1, comma negative 2, comma negative 2, comma 3, comma 3. That's Roman A. Roman B is the set of ordered pair. The set of ordered pairs in relation whose range whose range is zero, negative 27, 8, 1 over 105. So let us read the question before we solve. It's raining outside, so that's why we hear some noises. We should not hold because it won't last longer. You have to concentrate on the information that I'm teaching you. So the question states that what is the range? So what is the range? So what is the range of the following map? Of the following. So what the range of the following mappings? The following mappings. If the domain of H is all integers. If the domain, so this also it is conceptual question. Because you have to understand the concepts of mapping, otherwise you may get confused. So if the domain of each relation, so if the domain of each is all integers. It's all integers. So you have your question mark here. It's all integers. So I don't know if it is typing error, but you should not write the questions. You can solve the question even if that question mark is there. So X maps into 2 X minus 1. Then Roman B, you have X maps into X squared. Then Roman C, we have X maps into X cubed. So that's the question to be given. So remember that mapping is one of the styles that we can use in basic mathematics to represent the relation between two quantities. So mathematical relation. So what is the range of the following mapping if the domain of each is what is all integers? So you can remember I told you that I'm using a method, we call it in training in training aspect or in training department, we call it the active learning or active teaching system, where students is centered on learning process. So you are allowed to pause the video, to stop the video now, and take a rough paper, then solve example 27 on your rough paper, and then once you are done, you can click the buttons of play to see the right solution of example 27, and you can do corrections of mistakes that you have made during your trial time or during your practice time. Okay? Make sure to do that, and it should be a self-discipline. Because I know many students, they would like to see things, stuff more simplified. So solution. So solution, we say that a big given sorting, we have a range. So we say that the first state. So you can say data given or given information. So the given information, first of all, will be given domain. So domain of that particular range, that particular relation, domain of that particular relation is what? Is all real numbers. All real numbers. And then you'll be given a mapping for Roman A. You'll be given x maps to what? To 2x minus 1. Then we'll be given what? So we've been asked to find what? Range of what? Range of relation. This is what we require. One of the challenging topic in basic mathematics Form 3 during my time of learning, which is more than 15 years ago, 15 years, something like 14 to 15 years ago. It was relation. I didn't understand because the book I read did not help me to understand, so I did an extra work. So the second step now, we have to remember the concepts of what of mapping. So it means that express the mapping. So express the mapping in form of equation of the relation. So how do you express? So you say x simply say, yeah, so x usually say that maybe x mapping to y. So this is the first relation, was first ordered, it means first ordered pair, and this is the second set of ordered pair. So this is the first set of ordered pair of relation, and this is the second set of ordered pair. So this is the principle. So it means that for relation, you have to remember we told you that we use rate in this way. So relation x maps to what? To y. So what does it mean? So if you want to express now our relation in form of the equation, it means that this will be equal to what? So it means x maps to what? Maps to 2x minus 1. This will be equal to what? So it means that on left hand side we have what? Y, which is equal to 2x. It means that, for example, here we have equation 1, and this is, let's say, equation 2. Okay, so the third state, we say that compare, or just means that equate. Called equate, yeah, okay, so it means equate it. Equate equation 1 and equation 2. How? So it means simply in form of the equation, r y is equal to 2x minus 1. So simply it means that the relation can be written as what? Set of x comma y. Okay. So set of x comma y. Then we use a particular language that set of x comma y such that x is a set of what? So x is all real numbers. This is another way of writing the relation, the given relation. Okay? And what? Okay? And the y is equal to 2x minus 1. So that's the meaning. So after expressing the given relation in a simplified form, then now we can go further. How can you go further? Okay, this is the way that you have to go further. So the second step, we have now an equation. So steady state, we say that let us find what? Find the range of relation if the domain of a given relation is all real numbers. So for that case, it means our equation y is equal to 2x minus 1. So remember range. What is range? Range is a set of possible values of y, or dependent variable. We find range of a relation by making X the subject. What's domain? Domain is a set of possible values of independent variable, which means in bracket X. We find domain by making Y the subject of the equation. So it means that to find the range of this one, of a given relation, if the domains of R is all real numbers. So it means that we have to make sure we have to go into the first step. So this one will be the, okay. Yeah. Okay. So this will be the first step. So the second step, we say that now make X the subject. So make X the subject of what? So make X the subject of equation 3. So make X the subject of equation 3. So to make X the subject of equation 3, Y is equal to 2X minus 1. So to make X the subject, we have to add by 1 both sides. So left hand side we have to add by 1, 2x minus 1 plus 1. So here we have y plus 1 is equal to 2x. So divide by 2, and here divide by 2. So here we have y plus 1 over 2 is equal to what? X. So these is our equation that can help us to find range of the relation. So simply this, we can call it equation 4. Okay? So the first step now is what we call to find what? Range of relation if domain of relation is all real numbers. What it means of all real numbers? Mean that the value of x is from negative infinity less than or equal to x less than or equal to positive infinity. That's the meaning at the interval. So it means no boundaries. So now in order to, so we have all real numbers at the values of 40 of x, right, at the domain. So if that's the domain, then you have to think about what range, which is the value of x. Be given domain, you have to find range. Okay. So for this case, we say that in order to know the range, which is the value of y, so it means that any value of x that we substitute in equation 1 will give us the value of y. That's the simple meaning. Any value of x, because x, the values of x are from negative infinity to positive infinity. If you substitute into this equation, if you are looking at the value, because remember, range is a value of y, but we make x the subject when we are finding what is range. So it means range is the value of y, but we make what x the subject when we are finding what is range, and that the catch-up or ratio that we'll be finding. So when you substitute any value of x here, we get any value of y. So even substitute, maybe x is equal to negative 1 million, then we get the value of y. When substitute that x is equal to positive 2 millions, we get the value of y. So for that case, for the nature of the equation of relation, then we say that also range is a set of all real numbers. Okay? So it means that from this relation we say that, so therefore we say that range, because the question asks us what is the range. So therefore, say range of a given relation of what is, so this is the answer for Roman A. answer for Roman A, we say that the range of the given relation, which is R, okay, is a set of all real numbers. That's the response for what? For example 27, Roman A. So I want to leave example 27, Roman B as your homework. Let me do example 27, Roman C. Okay? If you have any question, did you understand how I solved the example 27, Roman A? Please tell me in the comment section if you have understood it or not. Because I'm ready to repeat several times and use different tricks until you understand, because understanding is the home of the person. So simply say that example 27B is your homework 8. So let it be your homework 8, your homework 8. So let me solve. So solution of what? Example 27C. So in example 27C, the summary, the informations will be given as the domains of real numbers, and then will be given B, because it's still the same question, C, say that X maps onto X30, X2. Okay? So this was, we ended there at the first step. So you have to follow also the first step, the fifth step, and the sixth step, 7 steps. So this will be the 8th step for Roman C. Should not confused about the numbering of the steps. These are just descriptions of what you are doing. So express what? So express the mapping of relation into question of what? Of relation. How do we do that? So remember that we told you that if you have X maps to what? To Y. This is the first state of, it's a set of values, the first set of values, then this is the second set of what? Of values. So for that case, you say that Y is equal to what? X2. So what is range? Or what are we finding? We are finding range of the relation. Range is a set of possible values of Y. But in order to find range, we have to make X the subject. Okay? We have to make X what? The subject. So you may make X the subject and you have to learn this. However, that's not too much important for this case, but later on, it's very important. Okay? So that's why we are preparing you for the future necessity. So the 9th step, we say that, so we said the 9th step, we have to say that, okay, make what? So suppose this is what? So suppose that this is, okay, question 1 for Roman C. So make what? Make X the subject of what? Of question 1 in example 27C. So to make it the subject, to make X the subject, you have to find out cube root of X2, and then you have to find cube root of X2. So this is cube root of Y. So here on this side we have to find cube root of 40 of Y. And here the cube root of X, we make what? So the name is X. So it means that we say range in the value of Y, but we make X what? The subject of the equation, of the relation, of the equation of relation. So this will be our second equation that we use to find out range. However, that we may come and test it here, but also we may use this equation to find out range. So the last stage, for example, 27C, last day, for example, 27 last step is the 10th step. So the 10th step. So the 10th step of example 27 is what? So now you can find what? Find the range of range of relation. Find the range of relation. Relation 40 of relation with mapping of x maps to x to x cube. So find the range of relation if you've been told that if domain of relation is all real numbers. So you have to think. Domain is all real numbers. The value of x is all real numbers. For example, so when you say real numbers, it means it's range from negative infinity to 0 to positive infinity. Okay? So if we take any value of x and substitute it here and find its cube root, we get value of y. So you can get any value of y by using any value of x. So it means that even the values of y also range from negative infinity through 0 to positive infinity of 40 of y. So from this fact, it's not common. Don't claim. Please, my student, don't claim about how we used to find range. Don't claim. You have to understand the concept. That's why that we are really insisting you to give us feedback in the comment section. Okay. So therefore, so you say that the range. So you say that because okay. So you say that according to the equation y is equal to x cubed of relation. Say that then its range, and the range of given relation is all real numbers. All real numbers. So for that case now, we conclude example 27, C, conclude that the range of relation is all real numbers. It's all real numbers. So that's the final response. So while you have one question, it's what of assignment. Okay, so let me write the homework. It's the time for the homework. Ladies and gentlemen, this is now a question for homework 8. In addition to that, and this will be example 28. It will be example 28. Okay, so I think that because we didn't deal with this kind of a question, let me do it. Okay, so it's a homework, but I'll give you, So it's a homework question, but I will solve one with you. So it means this is what actually is homework. Homework, I want to give you a concept, homework 8, and it is example 28, and it is concept. And where did I get it? Refer our recommended book that called Secondary Basic Mathematics, Book 3 by Tanzania Institute of Education, in exercise 1.3, question number 7, which is the last question. So the question states this way. Question number 7 to 9. So question number 7 to 9. So the question states that for each of the questions 7 to 9, each of the questions 7 to 9. So each of the questions 7 to 9, find the domain and range. Find the domain and range of the given relation. Of the given relation. Of the given relation. Seven is y is equal to x2 plus 3. Then question 8 is y squared is equal to, or y squared is equal to 4x. Then for question 9, we have y squared is equal to 4x. Isn't it? No. We have x squared minus y squared. We have x squared minus y squared. We have x squared minus y squared is equal to 1. So the way of solving these questions is the same. The aim, we have to find domain, this is number 8, this is number 7. Domain and range of the given relation. So this is the particular relation with an equations of y is equal to x cubic plus 3. This is the particular relations with an equations y squared is equal to 4x. And this is the particular relation with an equation x squared is equal to y squared is equal to 1. So let me leave this one, number 7, question number 7, number 8 to be your homework. And let me solve this one, question number 9, which might be a challenge for you. Okay? So we say that question number 8 and the 9, question number 8 and 7 are homework 8. You have to do homework 8. So let me solve. So solution of our example 28, question 9. So we've been asked to find domain and the range of the relation. So the summary of the given information, which are actually that we call the first stage, and we used to call it, because even in mathematics we have data. In short, you can call it data given. Okay, data given. So the first state data given. So you'll be given what question, be given a question of what of the relation R. So the question of the relation R is what? So for our case, it is x squared minus r squared is equal to what? Is equal to 1. Then what are we've been asked to find out domain of the range. So this is what required. Then we've also asked to find range of what of the range. This is what required. Okay. So second step. Second step, from the definition of what is domain. Domain is a set, okay? Domain is a set of possible values of dependent variable x. In relation, we find domain of a relation by making y the subject of the equation. That is the fact. So from the given equation of the relation, we have to make y what the subject. That's the second step. Then from there, we can find what domain. Be careful about that. So we say that make y the subject. So suppose that this is equation 1. Make y the subject of equation 1. So we have x squared minus y squared is equal to 1. To make y the subject, we have to add the y squared to both sides of the equation. So negative y squared plus y squared is 0. So here we have x squared. Okay, so you have x squared is equal to 1 plus y squared. So to make y squared, we have to subtract it by 1 to both sides. So here we are going to have x squared minus 1 is equal to 1 plus, or 1 minus 1 plus 1 squared. So for that case, I'm using a simplified language because I have a responsibility to teach slow learner, intermediate learners, and faster learners. So x squared minus 1 is equal to y squared. So if I write it means I just reverse, then y squared is equal to x squared minus 1. Do they make right the subject? No. Because when I want to make right the subject, I should have on left hand side or right hand side, I should have y power 1. So you have y power 2. So I didn't make yet y the subject. So you say y squared is equal to x squared minus 1. So I have to find this. Okay? So from here we have y is equal to square root of what? Of x squared minus what? 1. So domain is a set of possible values of x, our domains in a simple language, domain are the values of x, but we're making y the subject of the given equation. So we made y the subject of the given equation. So according to this equation that we have, what will be the conditions of x so that this equation, which you can call it equation 2, will be valid? So instead of be valid, it means that not all values of x here, if I substitute them, they give me the square root of 40. They give me. Remember that I'm not finding range, I'm finding what is domain. So it means that we have to define the value of x that actually can be used to, because remember that x, it is independent variable. So once you have x, we can find y. But if we make x the subject of the equation, x becomes as what? Dependent variable, while y comes as what? Independent variable. You have to listen to this because I will teach you, I repeat this concept when I'll be teaching about domain and range of the function. A real contradicting concepts. So for example, if I say that, for example here, I say that I want to put x is equal to 0. So it means that will be y defined when x is equal to 0? What will be the value of y? For example, we say y1 will be square root of what? 0 squared minus 1. So simply square root of -1, which is not possible for ordinary secondary education level to find the square root of negative numbers until we teach in advanced level or in ordinary diploma level about complex numbers, like the complex number. So we have to make sure that we avoid any value, or we have to avoid in all our computations of basic mathematics from 1, from 2, from 3, and from 4, which can give us the square root of any negative numbers. So from this testing that when x is equal to 0, so the equation 2 fails to give us the defined value of 40 of y. So from that point, we have to condition. Means the value of x should be conditioned, not all the values of x, because we substituted x is equal to 0, then we get -1. For example, also if you substitute x is equal to -1, you get the square root of -2. If you substitute x is equal to -2, you get the square root of -3. If you substitute x is equal to -3, you get the square root of -4, which does not exist for your level, but for we who have gone advanced secondary education, or who have studied advanced pure mathematics, by grace of God, also we studied higher engineering mathematics, okay, and higher scientific mathematics. So we know the complex number. For you, you don't know, and we are not allowed by the syllabus to teach you about complex number right now. Okay? So for that case, once you reach this step, this is just try. This is try. It's not important. This is just for you to understand. See the limitation. So once you have made y the subject, the next step now to get the condition of x is this. We say that, according to the observation, whenever you substitute any number which is less than 0, then the value of y will be undefined. For example, substitute x is equal to -2, x is equal to -1, x is equal to -3. So the question is what is undefined. So for that case, you just take what you have on right hand side, because we are finding domain. Remember that you are finding what domain. So that will be the third step right now. Okay, the third step. So the third step, let us find what find domain of what by using what? By using equation 2. I wanted to skip this part, but I thank God who we have invited and who is here. So it means we take the part of the equation, the right hand side of the equation, which have x, because domain, the value of what of x. So you see that we have square root of x minus 1. It means we can only find the value of y, or we can only find the value of y for that equations if the value of x is defined in such a way that this square root of x squared minus 1 should be greater than or equal to 0. Otherwise, the value of y is what? Undefined. Listen careful and watch this part several times as well as you can. So for that case now, we say, okay, we have now an inequality equation. So because we have an inequality equation, the next section, so we have to square both sides with the inequality sign. So to make what x the subject. So once we square both sides, we get what x squared minus 1. This is greater than or equal to 0, because 0 squared is 0. So make x the subject. To know means to know the exact condition of x. So please, I asked you, my student, repeat this subsection, repeat solutions of example of homework 7, homework 8, or example 28, question number 9, several times until you understand and you practice example 7 and 8. So you have x squared minus 1 greater than or equal to 0. So make x the subject. Okay? Make x the subject. So this is equation 3. So from here we say that the first step, let me write so you can remember. Make x the subject. Make x the subject of 40 of equation 3. So x squared minus 1 greater than or equal to 0. So then, so to make x the subject, we have to add by 1 to both sides. So greater than or equal to 0 plus 1. So -1 plus 1 is 0. So you have x squared greater than or equal to positive 1. Find the square root of x, find the square root of 1. So x will be greater than or equal to plus or minus 1. But just we take the plus sign. So from there now we conclude that this is still domain. The domain of relation R of relation R is what? Is given as what? X such that X, so such that what? So is given as, this is open curly bracket, such that what? X should be greater than or equal to 1 when you close dot curly bracket. So you're done for finding domain of the given range, of the given equation of equation 9. So the fifth step, I'm about to end this session, so you have to be patient. But now we're out of this, this is a very important concept, more than you think. So the fifth step now, we have to remind ourselves, what is range? Range is the value of y. Range is the value of y, but we make x what? The subject. Range is the value of y, but we make x what? The subject. So for that case, you say that the fifth step, make x the subject of the first equation, which will be given as what? The first equation, it was what? It was x square minus y square is equal to 1. So let us make x the subject. So add by y to both sides, 1 plus y square. So here we have what? X square is equal to 1 plus y square. So we are looking for x. So x is the square root of 1 plus y square. So now we have an equation for range corresponding to equation 2. So this, ladies and gentlemen, will be equation 4. Will be equation 4. So now the next equation. In order to find the values of x, what it means that if I plug any value of y, will equation 4 give me the defined value of x? The answer is what? Is no. I want to tell you that because of the length of this session 8, it might be taking 2 hours, I will break it into session 8A and session 8B, and I will arrange them in the playlist of relation. So I expect that. However, I will not tell you that the next part. So you'll find that session A, maybe it is 21 hours and some minutes, and then session B will be spending also some 1 hour and some minutes. So session where once session 8A ends, then session 8B starts. Okay? Pay that attention, because I realize this due to the complexity of the concept that we are covering. So now, for that case, we can go into the sixth step. We say that range is the value of y, but we have to make x equal to the subject. So we say that now, we just find range. Just find range. Range of 40 of the relation. What if we substitute? So what if like that? So you have to test. What if maybe y1 is equal to positive 1, positive number? So can I find the defined value of x? Yes. This will be 1 plus what? 1 square. So this will be square root of 2. It's a defined number. Then what if I have y2 is equal to 0? That is called trial and error. So will I get x? Yeah. So it means that x2 will be equal to what? 1 plus what is 0 square, which is equal to square root of 1, which is 1. What if also y is equal to negative 1? Then will I get x3? So here it means we have to check. We have 1 and we have negative 1 square. So it will be square root of 40 of 2. So because of y square, any value of y satisfies equation what? Equation 8. So you say that any value of y satisfies equation what? Satisfies equation 4 above. So due to that reason, range is a set of all values of y of relation. So the set of all real numbers. So range of this relation is a set of all real numbers. So therefore, we conclude range of the given relation is a set of all real numbers. Or you can write that range is a value of y such that y is element of all real numbers. So this is another way we can write. My dear students, that this is the end of session 8, which titled Solving Questions of Domain and Range. Yes, domain and range. But okay. So this is practice exercise. We will practice exercise to you. And this will make your example 28 or 29 and the 30. So because we are using the active training system, we want also to train our students on how they can find reference books for their advantage and how they can use them to find a particular information. So according to that, now I put the question here that refer secondary, because you can be writing everything on Blackboard and then for you don't know how to use the book. Secondary basic mathematics, book 3 by Tanzania History of Education, exercise 1.3, page 23. So, find the solution of question 2, no, question 3, and the 4. So you say that copy question 3, 4, and 5 in this exercise, and we solve each of the question, each of the given question. So from here, you find that all our online students will learn how to find a particular information or how to use the books, because later on, after maybe possibly because in Form 3, so from 4, after 3 years or 4 years, after 3 to 4 years, you'll be a student of university or institutions or college. So in higher learning system or in higher training system, you find that the lecturer can give you just the informations and the reference books. You have to go and read those books and summarize and actually prepare the notes for yourself. So because myself, I've gone through and nobody who had told me that when I was in Form 1, Form 2, Form 3, Form 4, Form 5, and even Form 6. So actually it was a real challenge, but I thank God because He has created a love of studying. Okay, love of studying, or of private studying. So to me, it wasn't a challenge because I had such kind of traditions myself, which God has developed in me since I was in primary education in 1990. In 1990s. Okay, so from there you have to find a question from the book, and if you don't have it, you can order it right now. And not only this one, you can order also some other books, reference books, secondary basic mathematics, book 4. We have also book 2, book 1 for figure, and then we have also ordinary level mathematics review. So you have so many materials in our Tanzania online bookstore. How can you place your order? Just send to me a message through this number 0759745331. Don't make a call. Just send a message. I will call you, and I can complete this business so that you can have this material to have your own library. So I would like to welcome all our Tanzanian pre-Form 3 or Form 3 or any viewer to our Tanzania online ordinary bookstore to access the materials that you need them in order to master every subject in O level. in O level. So then lastly, before we give God our thanks, read Exodus 25 verse 1 through 9 and Philippians chapter 4 verse 12 through 19. In case you feel from your heart you want to offer our living God, you are feeling thanksgiving for teaching you the beauty of basic mathematics free of charge. Real, this program is very expensive to produce. One video actually spend a lot of money, and it's expensive and awesome. For me, this is my offering, feeling thanksgiving offering to my living God who have given me a gift of teaching and who has called me by his love to be a national and international teacher of basic mathematics. So this is my thanksgiving. That's why I don't charge you. Just this every sessions is sent to heaven, and just always say in these sessions we remind God that my son Olenjolai, who has given him a gift of teaching, actually he's offered me a precious offering through all the Form 3 students in Tanzania and even in worldwide. So even yourself, the doors, the floodgates of heavens are open for you to offer your freely thanksgiving of any amount or any kind of the materials or resources that you know this one, they can actually they can promote this work, or they can promote this work to progress, to go further and further until the main objective is reached and the purpose of to also is revealed theoretically and practically and benefit the kingdoms of heaven. So you're warmly welcome. Even you feel you hear from your heart that you like to offer or plant a seed of 1,000 Tanzania shillings or 500 Tanzania shillings or even 100 Tanzania shillings, just send to us and we receive with the hands of thanks, and we keep praying for you for God to reward you. But before you send it, because we want you to offer by faith, send it by your own prayer to heaven, and then heaven will send to us, and as once we receive, we return it to heaven, and heaven return it to us, then we'll be using to pay the running cost for this program, so that in so many sessions of basic mathematics Form 3, Form 2, Form 1, Form 4 will be in air to have present and future generation to pursue the basic mathematics, the mathematics subjects and science subjects, and especially to prepare excellent engineers and scientists who like to manifest God's vision in Tanzania, that Tanzania is a country that is becoming an industrial country. So I have a responsibility to prepare engineers, mathematicians, researchers. So that's the responsibility. This is the foundation that I'm building, and this is my country. This is the gift that from Olenjolai to Tanzania. Okay? And from Olenjolai to African continent. This is a gift from Olenjolai to Asian continent. This is a gift from Olenjolai to American continents. The gift from Olenjolai to Australian continent. So that's all. So my dear students, it's the end of session. I thank God who have been with me and who really love me so much more than anything else, and is very close to me. And I thank God who have taught me a new concept in the midst of teaching you. I think that even yourself, you thank God. I thank God for you, for taking your time and join me. I invite you in the next session, that's session 9, when now I'll teach you about the concepts of inverse of relation. Okay, so stay tuned and keep enjoying the concepts of the beauty of basic mathematics. If you didn't subscribe, don't forget to subscribe, to click the icons of subscribe there in order for you to receive the notification. And you are free to share these contents to any students anywhere at any time. Okay? Remember also to ask your questions and give us feedback in the comment section. And tell us in the comment section you are enjoying this content from which region, from which secondary school, from which district, from which village, and how did you find these contents are relevant for you. So let us have Omega Thanksgiving prayer to our Almighty God. Our Father who is in heaven, I come before your presence in person. I don't know about my online students, but to me, I will give you thanks for the great thing that you have done in this session. I thank you for the revelation. I thank you for the language. Thank you for everything that you've done, Father. I thank you for the way you have simplified session 8 more than I have expected myself during the preparation. I give you all the glory and honor. Father, help all your online students to learn this concept and distribute it to all the pre-Form 3 students, to all the Form 3 students, to all the private QT students in Tanzania and Africa. Father, distribute this message and let everybody who is in demand of relation to meet with this session in order to understand and give you glory and honor. We thank you and give you thanks because you are good to us and for your love endures forever. We give thanks to the Lord of the Lords because you are love, because his love endures for us in us forever. We give thanks to the God of gods for his love endures forever in our life. In Jesus' name, amen. May God bless you. Thank you. Congratulations. Keep enjoying basic mathematics. See you in the next session. This is Olenjolai.